In my previous video, I casually mentioned that the limit existed because x approached the same point from the left and the right. And this is something I want to further explore in this video, the notion of one-sided limits, what the limit might be as x approaches a point from the left side and the right side. So that's what we're going to do here. And so I have a function of x drawn, right? So let's call this is the graph of f of x. And I want to look at the limit as x approaches -4 from the left side, right? And this is the notation for left. We put a little minus sign. So I want to look as x approaches -4 from the left. Now, if we look at how x approaches -4 from the left, we can see our point -4 is right here. And from the left side, it appears that we get closer and closer to our function of x being 5, right? So from the left side, with our knowledge of how to find a limit, we could say from the left side, as x approaches -4, f of x is going to be equal to 5, right? Now, what about the right side, right? Let's look at this notation. The limit as x approaches -4 from the right side, we put a little positive sign. And so let's look at that. By looking at our graphs, we could see that as we get closer to x equaling -4 from the right side, it appears that our function of x is also equal to -4, right? So, as x approaches -4 from the right, f of x is going to be equal to -4. So, we have two different answers for our left side limit and our right side limit. And when we have two different answers for those, we say that the limit of f of x, let's write this, the limit of f of x as x approaches -4 does not exist. And here's the little short notation for that, d and e. And the reason it does not exist is because for the limit to exist, x must approach the same point from the left and the right side, and that is clearly what is not happening here. We can look here, let's use a different color, let's use purple. We can look at our point as x approaches 9, for example. So let's look at the limit as x approaches 9 from the left side of f of x. And when we do that, we can see that as we're approaching from the left side, as we approach 9, f of x is equal to -4. Now let's approach from the right side. If we look at x as it approaches 9 from the right side of f of x, we'll see that we get closer and closer to -4. So in this case, our left and right side limits are exactly the same, meaning that the limit of f of x as x approaches 9 exists, and it is indeed -4. And we can see this graphically. This makes sense. Let's look at something else that might make a little less sense. So, right here we have the graph of the function, right? Let's use a different color for this. We'll use yellow. So here's our graph of f of x, and we want to look at the limit as x approaches 0 from the left side. So a little negative. F of x, there we go. What is this going to be equal to? Now, this isn't too clear, right? Because as we get closer and closer to 0 from the left side, you can see we just go further down and down and down, and we're not really approaching some finite integer. Now, because of this, some teachers or professors might say that this is unbounded, and they might just say that the limit does not exist. However, the way I learned it, and how I will teach it, is that the limit, as we can clearly see, the function is approaching -infinity. That is not a finite integer. We're just approaching -infinity. And then if we look at our limit as x approaches 0 from the right side, you could see something very similar happening. Our function seems to just grow up continuously, never stopping at some finite point. And again, teachers and professors might introduce this as saying, well, the limit is unbounded, it does not exist. We're going to say that the function is approaching infinity. And so therefore, since our function as x approaches 0, our limit is equal to two different limits. We've got -infinity and +infinity. Our limit is going to not exist. However, if you ended up in a situation where your graph or your function approached -infinity from both sides at a point, or +infinity from both sides at a point, then the limit as x approaches that point would be positive or -infinity. It just so happens that in this case, we have -infinity from the left side and positive infinity from the right side. So our function does not exist. If you found this video helpful and you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.